Hello everyone. Next topic in module 4 is allocation of frames and thrashing. So allocation of frames is like what is the number of frames given for each process. So this is what allocation of frames is. So each process needs minimum number of frames it requires. Like if a process has considered 10 number of pages to execute, then CPU is or the operating system is not given with 10 number of frames in main memory. It gives a minimum number of frames so that a process can execute the processing peacefully. Like minimum number of frames that can be enough to execute the process. As the number of frames allocated to each process decreases, the page fault rate increases, because if it has 10 frames, means 10 pages to execute, and it has minimum number like consider 2 or 3, then what happens? Page fault increases. So with the page fault increases, then number of page replacement algorithms to be used more often, and the process needs to wait until this page fault is solved. So minimum, of course, it's total frames in the system. It depends like what are the number of frames available in main memory. It depends on that, and it depends on multi-programming capacity. How many multi-programming is executing at a time. So based on all this, we have an example of IBM 370, 6 pages to handle SS move instruction. Instruction is 6 bytes, might span 2 pages. So 2 pages to handle from and 2 pages to handle to. This is an example of IBM 370. Two major allocation schemes are fixed allocation and priority allocation. So in fixed allocation, we have two criteria. One is equal allocation. As the name indicates, here in equal allocation, get the number of frames, consider it has 100 number of frames and 5 processes to execute in multi-processing. Then give 20 frames each for each process, so that in that 20 frames the process can execute. That is about free allocation. Next method is proportional allocation. Instead of giving it 20 frames, like equally dividing the frames and giving them, take the number of pages it has to execute. What is the degree of multi-programming? Then its size. So size of a process, based on the size, allocated proportionally. If you consider an example like S1 and S2 are the process to be executed, and S1 size is 10 and S2 size is 127, and M refers to number of frames in the system. So SI is size of a process PI. So S1 P1's size is 10 and P2 size is 127. So M is total number of frames. First you calculate capital S, in the sense total number of size. Like if you have PI process from 1 to PI, like summation of that SI will be capital S, means size of all the process to be executed. Then allocation will be size of each process divided by complete size of all the process into total number of frames you have. So here M is 64, S1 is 10, S2 is 127. So total S is 137. So for A1 means allocation for the process 1 is 10 by 137 into 62. That is proportionally equal to 4 frames. If I consider 4 point and we cannot allocate it with ratios like decimal points, we cannot allocate half a page or quarter page for a process, get into a whole number. So it is proportionally equal to 4, and for A2 it is 57. So out of 64 frames available in the system, process P1 is allocated with 4 and process P2 is allocated with 57. This is about fixed allocation. Based on fixed, we have equal and proportional. So equal is dividing the frames equally given for the process. In proportional, calculate the proportion based on the size of a process and allocate it. So next one is priority allocation. So instead of going for equal based on the priority allocated, so here in priority allocation, so if a process, if we have PI process and generates a page fault, for the process PI, if it is having a page fault, select a replacement of its frame, like one of its frame. Select like instead of 2, we have 2 methods here. Instead of going for other, select a frame in its frame itself, a frame, so that it can be replaced, or select a replacement of a frame from the process with lower priority number. If a process is having lower priority and your PI is having higher priority and you are not getting any victim page in its frames, then you can go for a frame which is holding a lower priority process. This is priority allocation. Next one is global versus local allocation. In global replacement, it's like our global variable. Any user function or any functions can use that variable. So here any process can take any other process frame for its replacement. It's like globally. So the main memory is having complete like frames. So any process in that main memory can use any other process page as a victim for replacement. So here we have two circumstances to face. The process execution time may vary greatly. So finding a victim and replacing it may take lots of time. Greater throughput, so more commonly used. Next one is local replacement. It is similar to our local variables. If it is allocated locally for one function, that to be used only by that function. So if a frame is allocated for one process, that process has to find the victim in only that frames available, then it has to replace. More consistent per process performance. There is no great like a great need of searching for a victim. It will be having minimum number of frames. You search a victim in those minimum number of frames, but possibly unrealistic in memory. It may affect the performance of a process while execution, because it may end up with more number of page faults. Next one is thrashing. Here thrashing is one set of one situation where your CPU your CPU's performance will reduce because of number of page faults. Like if your multi-programming increases, page faults also increases. Since page fault has increased, CPU's performance will reduce. So it limits your CPU performance. But thinking your CPU performance as reduced, the CPU operating system thinks there is minimum number of process in the CPU, means minimum number of multi-programming happening in CPU. So CPU utilization has reduced and starts allocating for new program for execution. So there are enough process executing, enough number of programs already executing, and facing a problem of page faults, all the process is busy in page replacement and CPU will go idle, or it will be having less utilization. But thinking there is less utilization, operating system will start allocating for more process for execution. So that condition is thrashing. A process is busy swapping pages in and out, so CPU utilization will reduce, and degree of multi-programming, thinking there is very minimum CPU utilization, degree of multi-programming will be allocated more, multi-program will be allocated more, and that period is called as thrashing. So methods to avoid thrashing is use local replacement, so that in using local replacement will be faster and it can reduce thrashing. So next method is providing as many frames as it needs for the process execution. This approach is defined the locality model. So locality model state is that a process moves from locality to locality. So set of pages that are actively used together, and this method can cause overlapping while allocating. Like if you allocate as many more frames as it needs, and it causes locality model, since it is moving from one frame, like one locality to another locality and actively used together, it causes overlapping in the main memory. Thank you.